So instead of writing explicit instructions, we show examples and let networks figure out the pattern. He predicts most software will eventually be neural network weights, not human written code. Now, I think we're a little ways away from that because I've worked with actual neural networks myself and built some of them, as well as built some of our own machine learning models. We're still a little ways away from this, in my opinion. I think we're going to have to hit some points where we're going to have to see some crazy advances in computing. I think even the 5 series, the new Blackwell level processors, are really impressive, but they're still a long ways away from being able to do this. So this isn't about AI replacing developers. It's about programmers becoming AI trained and architects. Traditional code is software 1.0. Neural networks are software 2.0. And we're in the messy transition period. The companies that master the transition will dominate, while those clinging to pure traditional code will become obsolete. So Karpathy's Let's Build GPT from Scratch video, which I showed you here, and which also is on karpathy.ai, teaches you how to code a transformer in 2 hours. He believes every developer should understand these systems at the implementation level, not just API levels. Most developers using AI are essentially driving cars without knowing what's under the hood. So building your own tiny LLM teaches you their limitations, their biases, and failure modes better than any other documentation. The difference between API users and builders is like script kiddies versus real hackers. His Nano GPT repository on GitHub has become the standard for learning transformer architecture. Now, Karpathy constantly refers to Richard Sutton's, quote, bitter lesson, end quote. That scale and compute beat clever algorithms every time. Every breakthrough in AI came from throwing more data and compute as simple methods, not from human cleverness. So engineers who try to encode human knowledge into systems always lose to those who just scale up learning. This is bitter because it means our human insights and domain expertise matter less than raw computational power. And that's part of the reason why I think computational power is one of the big limitations we currently have. Ultimately, LLMs are really impressive because they're using and unlocking like the GPU processing that we see at lightning speed. However, in order for it to get anywhere near truly thinking, we're going to have to actually see unlock of computation that is still orders of magnitudes farther away from what we have right now. So we can't just keep throwing more GPUs in larger data centers. This is actually going to have to get into different scales of computation. So the implications here are brutal because the company with the most GPUs wins, not the ones with the smartest engineers. And so that's the reason why we see this huge arms race going for these GPUs right now. So after a long time in tech, this is the hardest pill for experienced developers to swallow. Our cleverness doesn't matter as much as we think. Now, Karpathy is bearish on reinforced learning for LLMs, despite everyone hyping reinforced learning from human feedback, or RLHF. If you like this clip, make sure you check out the full Startup Hack Live video here because we've got lots more for you today.